If the cross-sectional area is increased, there is more space for the electrons to move freely, making less collision, so more current will pass through, making the resistance decrease. Let's perform an activity to explain that resistance of a wire is affected by its cross-sectional area.
Take wires of the same material and the same length but of different cross-sectional areas. Connect to a circuit. After connecting a particular wire, insert the key into the plug and note the reading of the ammeter. You will find that the value of the current is different from different wires. Since the same cell is used every time, the potential difference across the wires is same. We can verify this by connecting a voltmeter across AB. You will find that the thicker the wire, the greater the current. So, the thicker wires have less resistance than the thinner wires. Resistance is inversely proportional to the area of cross-section.
More the length of the wire, longer is the distance to be covered by the electrons, and hence charge, thereby reducing current and increasing resistance. Let's perform an activity to explain that resistance of a wire is affected by its length.
Take wires of the same material, say copper, and the same thickness but of different lengths. If the length of the wire is, let's say, L, the other wires should be of length 2L, 3L and so on. Find the resistance V by I of the first wire and then compare it with that of the others. We can notice that when the length is doubled, the current is halved. In other words, the resistance is doubled. When the length becomes 3 times, the resistance also increases 3 times. Thus, resistance is proportional to length. Apart from these factors, resistance also depends slightly on temperature. In general, resistance increases with increase in temperature. Higher the temperature, faster will be the oscillations of the ions in the conductor, and the moving electrons will have to undergo more number of collisions per unit length of the wire, thereby reducing time between successive collisions and reducing drift velocity of the electrons, which results in less current and high resistance. Thus, N is a consonant for a given material at a given temperature. It is called the resistivity of the material. The resistivity of the material is the resistance per unit length of a unit cross-section of the material. The SI unit is ohm meter.
The inverse of resistivity is called conductivity. It measures a material's ability to conduct an electric current. It is commonly represented by the Greek letter sigma. Its SI unit is Siemens per meter, that is S by M. Electrical conductivity is equal to sigma, which is equal to 1 by rho. Materials are classified as conductors, insulators or semiconductors according to their electric conductivity.
The values of resistivity of material determine their conductivity. For example, the conductors have low resistivities in the range of 10 to 8 ohm meter to 10 to 6 ohm meter. Metals with low resistivity behave as good conductors. Metals such as copper are therefore used for making electric wires. The filament of an electric bulb is usually made by tungsten because of its high resistivity values and the melting point, 3422 degrees Celsius. The insulators have very high resistivities in the range of 10 raised to power 8 ohm meter to 10 raised to power 14 ohm meter. Alloys like nichrome, nickel, chromium and iron. The alloys like nichrome also have the advantage that their resistance varies very little with temperature and they do not oxidize easily. And manganese, 86% copper, 12% manganese, 2% nickel, have 30 to 100 times larger values of resistivity than those of metals. This makes them suitable for use in the heating elements of electric irons, toasters, etc. Materials that have a resistivity midway between the conductors and insulators do conduct current, but very poorly at normal room temperatures, and so these are called semiconductors. The semiconductors have resistivities between conductors and insulator, that is, in the range of 10 raised to power minus 2 ohm meter to 10 raised to power 4 ohm meter. Semiconductors are widely used in the manufacture of transistors and diodes, as well as integrated circuits such as microprocessors.